Hello students, today our topic of discussion is work, power and energy. Literally we will discuss this work, power, energy in very detailed manner. So before going to discuss work, power, energy, first we want to discuss a very important concept, that is what? That is scalar product. That is scalar product. Now, you might be thinking that why I am discussing about scalar product and what is this scalar product. So before going to discuss this scalar product, I'm telling you that in this work power energy, scalar product is going to be very important factor. First of all of you know about product. Product means what? Multiplication. So whenever I'm telling that 5 threes are how much? 15. Whenever I'm telling that 2 fives are how much? 10. This is normal. This is normal multiplication. This is normal multiplication. So, but if I will tell you that 5 threes are 15, 2 fives are 10, or 4 fives are 20, if I will tell you that these things are not correct, if I will tell you these things are not correct, then you will be what? You will be telling what? Why? Because products are two types. One is scalar product, another is vector product. Scalar product means just the normal multiplication we used to do. 5 2s are 10, 5 4s are 20. These are what? This is actually scalar multiplication. But in vector, there are two types of multiplication. In vector, there are two types of multiplication. One is dot product, another is cross product. Yeah. In vector, there are two types of multiplication. One is dot product, another is cross product. Now you might be amazed that dot and cross. What are these two things? Dot and cross means, suppose in very normal way, if I will tell you, there are two vectors. There are two vectors. One is vector A and another is vector B. Okay. So whenever I'm telling two vectors are there, one is vector A, another is vector B. So if I want to do the vector multiplication of them, first of all, I hope you know what is vector, what is scalar, all this true stuff. Vector means what? Vector means those who are having both magnitude and directions. Scalar means what? Scalar means those who are having only magnitude, not in directions. Whenever I'm telling dot and cross product, dot product, what is this meaning of dot product? Dot product means, suppose there is a vector A and there is another vector B. If I will check the dot product of them, then it will give me A mod B mod cos theta, where theta be the angle between them. Theta is what? Theta is angle between A and B. Theta is nothing but angle between A and B. So you might be amazed that this is dot product AB cos theta. Actually, this dot product of this vector is known as scalar product. This dot product of this vector is known as scalar product. So let me clear you what is this dot product or scalar product. Suppose, let me take one vector A. Let me draw it. Let me take one vector A. Let us consider I am drawing a vector A. Okay. A vector A I have drawn. Let me draw another vector B. Another vector I have drawn. Two vectors I have drawn, A and B. What is the angle between them? The angle between them may be theta. So we have drawn two vectors A and B, and the angle between two vectors is what? Theta. Theta will be the angle between two vectors A and B. Now if I will tell you the projection of B over A, what I'm telling? Projection projection of B on A. Means if I will take that, suppose this is the B vector. B vector is projecting upon A. What is the meaning of projection? You see, B vector. B vector has one component along A direction. This B vector, this has one component along A direction. Uh, let me show you by another example. Suppose this is the B vector, this pen. This has one component along A direction, right? And one component along perpendicular direction. So whenever I'm telling the B vector, the projection of B vector on A, so I can tell, let me take it. I can tell it is B cos theta. How much it is B cos theta? Now you will be amazed how it is B cos theta. So let me draw it clearly. Suppose I'm telling this is vector A and this is vector B. This is angle theta. Suppose the perpendicular drawn from B to A, this might be X. Okay. Now, what is the formula of cos theta? And this base, let me draw this base. Actually, this is a vector. Let me draw this base as Y. Okay. So, what is the formula of cos theta? Cos theta, as we know, cos theta equals base by hypotenuse, right? What is the base? Base is here Y. What is the hypotenuse? Hypotenuse is here B vector. Now if I take the magnitude of B vector over here, what if we are taking this much as the magnitude of V vector? So cos theta can I write? Let me show you. Cos theta I am writing Y by B. Why? Why I am writing Y by B? See, cos theta is what? Cos theta is, we know, base by hypotenuse. Now here we have taken two vectors, A vector and B vector. Okay, and the angle between them is theta. Now the magnitude of B, I am telling the magnitude of B vector along the direction of B is mod B. Okay, so this magnitude is mod B. Let's consider this magnitude. This magnitude let be Y and this perpendicular let be X. Okay, let us consider it. So we know what cos theta equals base by hypotenuse. So Y by B, that is equals to cos theta. That is equals to what? Cos theta. So along the direction of A, I can write the magnitude of A will be Y equals B cos theta. Right? Along the direction of A, we can show that magnitude is B cos theta. So similarly, if I tell you that projection of B on A means I am taking two vectors. Let me take it very steadily. Sorry for the interruption, students. These two vectors, one is vector A, okay, and another is vector B. One is vector A, another is vector B. The angle between them is theta. So let me tell you, if I am telling the projection of B, what I am telling, projection of B on A, then I have to draw perpendicular. So this portion is gonna be B cos theta. So projection of B on A, I am repeating it again, projection of B on A, that will be B cos theta into A. So if I am telling projection of B on A, that will be B cos theta into A. And if I would tell you projection of A upon B, projection of A upon B, projection of A upon B. So I have to show you another thing. When I am drawing projection of A upon B, let me show. So what if I would tell projection of A on B, projection of A vector on B vector, then I have to tell that first you have to draw the perpendicular over A. After you have drawn perpendicular over A, so this component will be A cos theta, and this is the angle theta, obviously, sorry. So whenever I am drawing projection of A on B, what I told projection of A on B, that will be A cos theta into B. So whenever I am telling two things, so here I am drawing two things. Let me clear you. Be very clear about this concept. Two vectors are there, A vector and B vector, and we are going to take the dot product of the two vectors, as we are discussing that in the vectors there are two kinds of product. There are two products. One is dot products, one is cross product. Cross product is not in our topics of discussion today. So if I am telling the projection of B vector on A, projection of B vector on A, then these will be B cos theta into A, B cos theta into A. And whenever I am telling projection of A over B, that will be A cos theta into B. So be very specific. So if I will conclude the scalar product will give you A dot B. A dot B will give you what? Let me rub it. After that, I'm showing you. Whenever I'm telling A dot B, A dot B. So this scalar product will give you mod of A into mod of B and the angle between them, cos theta. Now you might be asking, sir, what is mod of A, mod of B? Mod of A is nothing but the value of A, the magnitude of A. So if I am telling mod of A as A and only A, value of A, mod of B as only B, so AB cos theta. So this is the dot product and scalar product, dot product or scalar product, and this product is completely scalar. It has no direction. So it might be written that A cos theta into B, that means projection over A, projection of A on B, and it might be written B cos theta into A, that is projection of B on A. So that's all for the scalar product. But if I am telling you what is the relations in our chapters work, energy and power. So whenever I'm going to discuss about the definition of work done, আমরা যখন ওয়ার্কের ডেফিনেশন ডিসকাস করব, whenever we are going to discuss the definition of work done, so two things we have to keep in our mind. Two things. First, let me see what are the two things. So let us draw a picture. Okay, I hope you will be understanding the picture. So let us draw. This is an object. Okay, let's take it very simple. This is an object, box, I think a box. There is a box. Now it is kept over a surface. Now you are applying force along this direction. Okay, So this is a box and you are applying force along this direction. Which direction? Suppose there is a ground surface is parallel to the ground. With respect to ground, you are applying force making an angle theta. Making an angle theta, you are applying the force. Now, whenever the box has displaced some distance, means now the box has been displaced by the distance. Suppose it was the initial position of the box and it is the final position of the box. Okay, first one is initial position and second one is final position. So whenever I'm taking the initial position, initial, and it is final. Whenever I'm giving a force, force is making an angle theta. Theta with whom? This is the horizontal. With horizontal, force is making an angle theta. And these dotted lines are parallel to the horizontal surface. These dotted lines are parallel to the horizontal surface. And the distance between them might be d. So force and d. Now, if I would like to ask, if I will ask you, what is work done? Then the work done definition will be work done by the force is defined as the product of component of force along the direction of displacement. Now the things gonna be very clear. Component of force. Force is a vector. It has two components. Along this direction, along this direction. It has two components. One is along the direction of displacement and one is along the perpendicular to the displacement. One is, suppose I'm taking it along x, I'm taking it as along y. Right? Along x direction, force is one component. Here I'm drawing, this is force. Okay, force with x axis, force is making an angle theta, and with y axis, force is not making an angle theta. This is 90 minus theta. If total angle is 90, total is 90. If this is theta, this will be how much? 90 minus theta. So along x-axis, the component will be how much? F cos theta. So along x-axis, the component will be f cos theta. Along y-axis, the component will be f cos 90 minus theta, f sin theta. Along y-axis, the component will be f sin theta. Okay. So if I am telling what is work done by the force is the product of component of force in the direction of displacement. So if I will analyze the component of force, this is the force. The component is along x direction, means along the direction. Displacement is in which direction? Displacement in this direction. Displacement in this direction. No? Displacement in this direction means, you see, displacement is this direction. So if I am taking this component, so this component is how much? F cos theta. This component is how much? F cos theta. So if I write down the product of component of force along displacement, that is F cos theta, and the magnitude of displacement, that is d, F cos theta into d. So I can write work done equals Fd cos theta. Work done equals Fd cos theta. That means if I generalize the work done, so please always remember what is work done. It is the component of force. It is the product of component of force. What I told? It is a product of component of force along the direction of displacement and the magnitude of the displacement. That means it is product of component of force along the direction of displacement. F cos theta is the force component of the direction of displacement. displacement along, there is one direction, along the direction of displacement there is one component, that is f cos theta, and perpendicular component is f sin theta, and the displacement is d. So f cos theta into d work done equals f d cos theta. So if I generalize it, this as a vector format, so in vector format work done equals, if I write w equals f d cos theta, if I generalize it, as we have studied today only, that a dot b is how much, a dot b ab cos theta. Now you are getting why I have started with the scalar product, as we know that a dot b is ab cos theta, so w equals f d cos theta. So if I can write work done equals f vector by d vector. So force dot displacement, so work done equals force dot displacement. That means if I will just what I should tell, if I will generalize this, that means work done is the product of component of force along the direction of displacement. Means suppose you are displacing, means if I'm just generalizing this for you, I'm just telling simply, suppose an object is there and you are displacing along this direction, so displacement is d. Now work done is what? Component of force along the direction of displacement. Means if you are giving force and in this direction, then force has two components. One is in this direction along x-axis, along y-axis. Means in 2D we are telling. So along x-axis, along y-axis. And if force, this force make an angle theta with the horizontal, so this direction along the direction of displacement along the force component is how much? Along the direction of displacement, force component is f cos theta. Along the direction of displacement, force component is f cos theta into this magnitude of displacement. So work done is product of component of force along the direction of displacement, just I'm emphasizing on the word along the direction of displacement, and along the direction of displacement, what is the component? F cos theta into magnitude of displacement. How much? Only d. So if cos theta into d, that means f d cos theta. So that's all for the, that is the thing, that work done equals f d cos theta, vector dot d vector. Okay, this is the basic of the